Alright, for this one, you want to set all your things up. That's what you have. This is going to be your equation, and you want to put an R in for that. So it would be and then after that, it would be and then you want to do the derivative. It would be 40. Then you want to solve for dt. Well, h is going to be 2, so that would equal 4. So dt will come out to equal 12 over pi meters cubed per second. Alright, for this problem, you want to set up your things again as well, but this time it's with a circle. So your r is going to be 5, and your derivative of r is going to be 2. This is going to be the equation you use, and you're going to take the derivative of this equation, so it'll be dA over dt equals t pi r times dr times dt, and then you want to plug in those, so 2 times r, which is 5, and times dr, which is 2, and then your answer will be 20 pi meters squared per second. And that's it.
So for 6, a fish is being reeled in at a rate of 2 meters per second by the old man by the sea. If he is sitting 30 meters above the water, how fast is the fish moving through the water when the line is 50 meters long? So we're given the rate at which the hypotenuse is changing, which is 2 meters per second. We're given the y, which is 30 meters, and the hypotenuse is 50 meters. So we want to find the rate at which x is changing. Since we have the hypotenuse and the y values, then we can use the Pythagorean theorem to get the x value. The related equation we use would be the Pythagorean theorem. Then we would derive the equation. And just plug in the values. So x is 40. We don't know dx over dt yet. Y is 30. And dy over dt would be 0. H is 50. And dh over dt is 2. The answer is 2.50 meters per second. So the fish move through the water at 2.50 meters per second. 7. A spherical balloon is being inflated such that its volume at time t is given by v equals 3t, where time is measured in seconds and volume in cubic meters. How fast is the radius increasing when the radius is half a meter? So we're given the radius, which is 0.5 meters, and we're trying to find the rate at which the radius is changing. So the equation for the volume of a sphere is 4/3 pi r cubed. And we know that would equal 3t. Then we would derive both sides. Then we would plug in 0.5 for the radius. And then divide 3 by 4 pi 0.5 squared to get dr over dt to equal 3 over pi meters per second. So the radius is increasing by 3 over pi meters per second when the radius is half a meter. (7b) A spherical balloon is being inflated such that its volume at time t is given by Vt equals 3t, where time is measured in seconds and volume in cubic meters. How fast is the radius increasing when time is 12 seconds? So we know that volume is 3t. And when you derive that, you get dv over dt equals 3. And we know that time is 12 seconds, so 3 times 12 equals 36. So 36 is the volume. We're trying to find the rate at which the radius is increasing, and we would use the volume equation for a sphere, which is 4/3 pi r cubed. So first we would want to solve for the radius. We know that v is 36, so we would divide this by 4/3 pi. And then cube it. So r equals that. And then we would want to take the derivative of the volume equation. We know that R is this. We're trying to solve for dr over dt, and dv over dt is 3. So now we solve for dr over dt. And we should get 1 over 12 pi to the 1/3. So the radius is increasing at a rate of 1 over 12 pi to the 3rd meters per second at 12 seconds.